Hi, everybody. Welcome back. Thank you for joining our next session. I'm really excited about this particular talk. I'm very pleased to introduce David Colwell, who's Vice President of AI and Machine Learning at Tricentis. The topic this time is particularly pertinent and topical at the moment, enabling low no-code testing with artificial intelligence. So, David, I will hand over to you.
Thank you very much. Okay, I'm going to do my best to share my screen. So if everyone can let me know if this works out, that would be great. All right, you should be seeing a presentation on screen right now. It might swap briefly back to this until I move it away. Ah, beautiful. Thank you to whoever has found the loves, the hearts, and thumbs up buttons on the emojis. Really enjoying the interaction. So, thank you to everyone dialing in from, I understand, Singapore, India, and Australia, and some people even in New Zealand today. It's really good to be with you all to give you some information on artificial intelligence and low-code automation. Before I start, I'll give you a brief introduction to myself. My name is David, but I go by Dave. I'm the Vice President of AI and Machine Learning at Tricentis, and I think what I do for work, that's interesting. Don't get me wrong, I love artificial intelligence. It's this rapidly changing and evolving technology landscape. But I think more interesting than what I do for work is a little bit about me personally. I love to build things. I love to build furniture. I love to build structures. I love to build, in this case, boats with my kids as an activity to help me and them have some bonding time. And I think the reason that I love building things so much is because we live in this world where everything's virtual. We create software, we build tests, and all these things, you never really see and feel it. And so I love, after work, getting out there and just doing something with my hands. And I think that tells you probably quite a lot about me. It also probably tells you a little bit about how this presentation is going to go. We're going to be trying to do this in the form of a story. So instead of trying to talk at you and tell you all about artificial intelligence and what it is and how it works and all the mechanics of it, that, to be honest, there are people that are much smarter than me on YouTube that can tell you that information. I'm going to give you a bit of this background that I have, my background in testing and quality assurance, and try to bring it into the world of artificial intelligence through the medium of travel. So the first thing that we're going to do is we're going to engage in a little bit of a thought experiment. Now, I've tried to localize this as much as I can. I'm going to use Singapore as the locale. I've only been to Singapore maybe 5 or 6 times during my life. And in this time, I was staying with a friend who lives up in the northern part of Singapore, and he lives in a province called Sengkang. And our job is to travel, and we need to go to a particular location, the Balestier Plaza. And the purpose of this trip is to engage in some shopping. So that's our requirement, to go from my house in northern Singapore in Sengkang down to the Balestier Plaza to engage in some shopping. And if I was trying to design test cases around this, I would need to start to elaborate on that requirement a little bit. So let's do this. I know one thing about my shopping trip. I've got a fairly big list of things that I'm going to need to go out and get. So, okay, big list of things, that's going to require a vehicle. I also know that for those of you that are from Singapore, the cost to get a vehicle registered is moderately expensive. So we're going to go all out. We're getting a really good car because, price difference between that and a Prius probably isn't that big. So now we've clarified our requirement. We've got a big list of shopping to get from the Balestier Plaza. We live currently in Sengkang, and we're going to require a car. So we've clarified our requirements. We've nailed it down. Next thing, we need to plan our route. Now, many of you wouldn't need me to tell you how to plan the route. I give you my address and you'd probably go, yep, I know where that is. I can use my past experience to be able to find my way to that, to Balestier Plaza. I don't need anything external. I've lived in Singapore for years and years. I can do this all on my own. But there's some of you that are like me. You're not from Singapore. You don't have that past experience. And so whereas an experienced subject matter expert would be able to do it off the top of their head by the experience that they have, us that are newer to the domain would need some assistance. Now, in the testing world, often this assistance comes in the form of documentation. Now, I don't know if any of you remember this, but there is a form of documentation for streets. That is the street directory. And I actually found out that there was a 2020 edition of the Mighty Minds Street Directory printed for Singapore. Who knew? I don't know who it's being printed for, but it does exist out there. And so we might need to go through and read the documentation. Now, here's where it gets a little bit difficult, because that person that has deep experience is very easily able to create a test case like that. They can map the path through the application super quickly. But the people that don't have that experience, they need to build it from gathering experience from these documents. And that can take time. I don't know if any of you remember trying to navigate with street directories, trying to find the C4 where the street is labeled and move your way around. And then you try to say, oh, should I be turning left or should I be turning right here? I don't know. Let me sort of move a bit further along. And that's, oh, no, wait, that's a one-way road. It was a painful experience. And in testing, when you're new to the domain, that can be a painful experience too, trying to make your way through the app, make your way through the domain, figure out what everything means. It can be really difficult for somebody that's just come in. And so an experienced person, great, they probably know their way. An inexperienced person, they need a bit of guidance. So now we've got our test, we've clarified our requirement, it's time to execute it. And there's one thing that I know is common to India, Australia, Singapore, and New Zealand, and that is that as soon as you get in the car to drive, to execute that test, you're probably going to get stuck in traffic. I live in Sydney, Australia, and at the moment, the traffic is not that bad, comparatively speaking. I've been to Mumbai in India, and I can say comparatively the traffic is nothing. But also, I made the mistake of trying to get to the airport in Singapore to travel home during peak hour. And what looked like quite a short trip on the map turned out to take nearly 3/4 of an hour. The feeling of driving in traffic is similar to that feeling of running a test manually. You're doing something, you're just kind of like, okay, I know where I need to go. It's just taking a while to get there. I wish that there was a way that I could make this whole process of figuring out what I need to test, creating that test, the plan, and executing that test. I need something to help me make that faster. And the good news is that most organizations are in the same boat. And we got these figures externally. This is actually from the GitLab DevSecOps survey from 2021. And I was shocked that still 80% of the testing that was being invested in was still being done manually, even in these fast organizations. This was slowing down deployments, costing people a lot in maintenance, and it was resulting in low risk coverage and low end-to-end automation. But hang on, automation, that's it? We don't need to drive the car manually. We can get a robot to drive the car for us. This is the automated approach. Why are we talking about manual? The robot can drive the car. Can't it? Well, this was what we thought. This was the initial, I guess, some people would say snake oil, but this was the dream that we were sold in testing was, well, you're not going to be the one running these test cases anymore. You just write some automation, cut the script, and then let the robot drive for you. Let the robot will take your app and he will cover it off. It would be just like trying to get a robot and get him to drive you to your destination. And just like this guy in the background here looks a little bit skeptical of being driven by his robot, testers the world over were a little bit skeptical of this dream that we'd be able to just have robots take all of this work over for us. And the reason is because just like a road, our applications are subject to change, shall we say. These changes come in a lot of different ways and a lot of different shapes. It could be things like application changes, these detours in the road. It could be that your app's performance is unreliable in whatever environment you have it in, your testing or dev environment. The app could encounter bugs or unexpected environmental issues or pop-ups. And all of these things are not necessarily a problem for a skilled driver like yourself, or in this example, for a manual tester. We didn't really notice these things. If you had to wait 10 seconds instead of 20 seconds, didn't really cause any problems. You're just slightly more irritated that the traffic jam was long. But robots, they're not very dynamic. They get their instructions and they run through these instructions. In fact, that's kind of what we want them to do. We don't want them getting adventurous and going off and doing their own thing. But that means that they have a certain script that they're running to. And when deviations from that script happen, the robot breaks. And you can be smarter or less smart about how you build the script, but at the end of the day, you're telling them to do something very discrete, and the robot does not have very much intelligence to be able to decide which direction to go, to the left or to the right. And this results in fragile automation. It requires a lot of skill to build. It's very technical. You end up with code being to test the code. And it makes it very difficult to understand what's important. The example script that I got there was very complex. It was actually doing something moderately complex, but even me, as a person that writes and understands code on the regular, it would take me quite a long time to understand what that script was doing. So definitely more towards the street directory style of navigation than something more elegant. So we've thought, okay, manual is hard, it's time consuming, but at least we know it works reliably. Automation, that's fast, but it can't adapt in the way that our manual brains can, and it requires a very high degree of technical expertise. So we're kind of stuck in a bit of a jam. We've got these problems. It's hard to build this good test. It requires a lot of effort and a lot of work. It's not something that's fun to execute in any meaningful way, and it's difficult to make it adapt to change. These three problems are really the core problems that have been driving testers nutty for the last 20 years or so. And if I just said, okay, we've got these three problems, that's it, talk over, then that wouldn't be a very motivating talk. What I'm going to do now is show you in two phases the journey that's in front of us and what we can do to deal with these core problems. Some of it is going to be things that you can take away and do today, things that you can just pull open source libraries or improve your skill sets, or hire the right people, and you'll be able to fix some of these problems or at least improve them. And some of it is going to require artificial intelligence. When we talk about artificial intelligence, it's sort of inevitable that we start talking about tooling, because artificial intelligence either needs a company with a deep investment in deep learning, machine learning engineers and data scientists, or you can basically pay someone else to have done all that for you. So where do we want to end up? Well, in the same way that we kind of want our cars to end up being self-driving so that we can focus on what we want to do, which might be reading the newspaper, although personally I do like a good audio book. We kind of want all of those boring parts of testing, the parts that aren't really adding value, they're just consuming time. We want a machine to be able to take those away from us, to make those parts of our job disappear so we can focus on what's important. In this gentleman's case, apparently page 6 is quite important, but in our case, we have other things that we need to be dealing with. We've got the bigger questions of where is our coverage missing? What are our outstanding risks? How are we going to go about optimizing these test portfolios? Problems that require a much, much higher brain power than the problem of my test just broke. What code do I need to update to fix it? So this is the goal, and that goal is generally accepted to be reached in two stages. Where we are at the moment, the sort of script-based test automation is going to evolve into a model-based or no-code automated approach. And that's where we're going to focus a fair bit of the remaining part of this talk on what is no-code and how do we get there. But we're also going to be showing you some of the next generation after that, which is the AI-powered automation. Specifically, we're going to be talking about how deep learning, the most advanced current form of neural networks in machine learning, are able to accelerate automation beyond even what we can achieve with no code. So the foundations of no-code testing are, in fact, the inversions of the problems that we had before. The problems that we had before were that it takes a long time to write good tests. We've got have to drive them manually, and that we need to deal with changes. So to solve that, we need rapid test authoring that's accessible to everyone, hands-off test execution where it can run by itself, and a machine that knows how to navigate that road, a machine that knows how to deal with changes in the application. And when we talk about rapid test authoring, the current state is generally accepted that testing happens after the build. You need an app in order to test an app. However, we focus time on saying, well, how can we use low-code techniques to enable more people, simplified record and replay, more people involved? We want to shrink that window. We want to bring it down. And this is a form of rapid test authoring. In fact, it's the most popular form at the moment. And there's tooling out there at the moment that can help you with this, things like Testin or Cypress or many of the other libraries that just make it much easier, much more accessible to code and much more accessible to build with no code. However, if we really want to move fast, we actually need to think a bit more about shifting that window. Can we move the testing window from happening after the build to happening during the plan and during the build? And that's where something like deep learning automation will come in, that third generation of test-driven automations. So let's have an example of this. This is a research project that Tricentis did back in 2020. It actually turned into a product that we called Vision AI. We based it on the premise that you should teach a machine, instead of looking at HTML and Java and everything else, to see the screen in the same way a human does. So here we had a human doing a test, and the AI was watching them and annotating the screen, saying the inputs in orange, the tables in blue, the tab bars in green, and so on and so forth. The different controls were all annotated on the screen by the artificial intelligence. And the goal of this was to try to make our automation more like the humans, because we know humans don't have problems dealing with changes in applications or even drastic changes in technology. So if we can bring the artificial intelligence closer to a human understanding of the application, then we can use them to enable the construction of automation before the test case is ready and the stabilization of that automation. And the result after we'd built this product was that you could take an existing test case, and in this case, we had a requirement. And that requirement was pretty simple. We've added a new field, this fuel type field. But the app is not yet ready. All we have is a mock-up that was given to us during the design. So using Vision AI, we were able to say, that's not a problem. You can scan that mock-up. You can build a test based off that mock-up. And your entire test with no code involved, so again, the generation from no code to AI-driven automation, you can have that test built and ready, even though, as you see here, the application doesn't actually have a fuel type field in it. The code hasn't been written, but the test is ready. The test is failing because the app isn't ready, but the test is ready before the app is even built. This is truly shifting the testing barrier from being over here at the end of the cycle to being during the development. So now let's update. The code is ready. Great. The fuel type dropdown is now present. Don't change the test at all. The test has been ready from the start. Let's just run it. Okay. We can run it against the mockup, or we can run it against the real app. And here, with no change to the test keeps running. This is how AI can really change the game. because if we were to just consider things in terms of the scripts you can write and the automation you can do without the machine there, we'd never approach this degree of speed. AI is the only way that you're going to be able to move beyond the consideration of just the app to enable you to build the automation before the app is ready. In this case, deep learning driven automation systems. It's the only way that we're able to achieve fully stable hands-off execution and make our changes resilient no matter what the application does. So that's my talk for you all today. Thank you very much for your time. I will be taking questions for the remainder of this period. And I'm going to bring Alec back in.
Thank you very much indeed, David. It's a great session. So it's really topical at the moment because we hear more and more questions, and we're putting these conferences together. People want to know about low code, no code, and AI. It's certainly very hot topics right now. So thank you. I'll just look at the questions. There's a few coming in. Should I read them out and then pick a few?
I might pick some of these because we're getting quite a few.
Sure, no problem. I'll hover in the background and.
Thank you, Alec. Just give me a timeout because I could read these questions all day. I love it.
No problem. We've got about 9 minutes, I think, before we need to go.
All right, perfect.
Demo session.
I like this first one. What are the limitations of no-code AI as per you, and how to overcome them? That's a really good question. There are limitations of no-code and limitations of AI-driven testing, and those limitations usually occur when you need very deep control over certain parts of the application. So let me give you an example. We were testing an application for a customer. They're a stock exchange customer based out of Sweden. And when we were testing this application, the no-code tooling was built around general no-code concepts. It understands the apps in general ways. But their app needed a very specific way of setting and removing browser cookies during the application. Specifically, you needed to write a particular piece of code, an algorithm, to be able to set and unset those cookies and to encode the values into those cookies in the way that the app understood. Otherwise, it just didn't work. The no-code part took care of the UI just fine. It took it driving the APIs and all of that. But this very specific application behavior, if we didn't have a capability within the no-code to still dive into code when it's required, then you get blocked. You kind of get stuck at that point. So it sounds controversial, but whenever you're looking at a no-code or an AI-driven platform, something you should always ask is there a way out of this? Is that the only way we say to do it? Whether you build the no-code platform yourself or whether you buy one off the shelf. If you're saying the only way to do this is by using the no-code component of this platform, it's inevitable that at some point you'll run into a situation that the platform has not been designed to deal with. And if you don't have an exit from that at that point, then you're going to get stuck. The next one is around security. Security is the utmost priority, not just at the moment, but for a long time now. Very good point, Oscar. How safe are low no-code platforms? The low or no-codeness of it doesn't really have much of a bearing on the platform itself. Some questions, though, that I would recommend you ask are mostly focused around data, actually. A lot of low and no-code platforms will require your data in one way or another. So you should look at, do they train using your live data? How do they store that data? What is done with that data and who has access to that data? In addition, you should look at execution ingress whenever you're using a platform-based execution. So, for example, if the execution comes in from the cloud, then ask, what can that do? Once that agent is in my environment, can it run anything? Can it fire off command? These are some of the questions that you should ask, not necessarily just about low and no-code test platforms, although the training data is very specific to AI-based ones, but any cloud-based or external testing platform. Dig into those two places because, in my experience, they're the biggest parts of the security holes that you see. Is low no code going to be the future of AI? Low no code currently looks like the future of a large number of different technological directions at the moment. We're seeing low no code app building. We're also seeing low no code AI creation. There's some wonderful tools out there. I think Microsoft makes a good one. Amazon's SageMaker is a great example, where they're trying to even make the task of building an artificial intelligence something that you can do without code. So I think low no code testing within artificial intelligence low no code testing and artificial intelligence enabling that is at very least going to be the future of the next few years of testing. I don't see if there's a question in here. I don't see if there's a question in here about the next generation of testing after that, but I'll provide my opinion on it anyway. I don't believe that we're going to really get to the point where it's fully hands-off, where the testing car drives itself completely. And the reason for that is I believe the test will be able to drive you. So the platform will be able to drive you, but I don't believe it'll be able to tell you if it is seeing the right thing without a human intervention. For example, I created an account and then I processed a transaction. What should the new account balance be? Well, that's not a super simple question to answer. You need to model the behavior of the application. So I believe that the future of testing and artificial intelligence is going to be low no-code results, AIs augmenting humans, not AIs being our robot overlords, to steal the phrase from The Simpsons. Do we have a few industries or products targeted that it suits best? In general, if you're using AI-based platforms, your biggest industry divider is going to be data privacy and concerns. As long as your organization is comfortable with cloud, it works moderately well. And on our low no-code platforms, we've got even really conservative organizations, Swiss banks, government organizations, everyone. One where it is a little difficult at times to use the low no-code, like the AI part of that, is in defense research and health sciences. Anywhere where you have really strict NDAs and air-gapped environments are often quite problematic. According to Google Trends, the interest in no-code ML is increasing, but people interested in traditional ML are far ahead. Your views? Look, traditional ML is miles ahead of the capabilities of low no-code machine learning. And here, when you're talking about the Google trend, the specific categories that are being trended there is machine learning as a capability and low no-code ML platforms like SageMaker and Azure Deep Learning ecosystem. And the reason for that is because AI is still very much an evolving discipline. Every day there's a new research paper out saying, I've just discovered a new way of optimizing our algorithms. And the low no-code platforms, they take time to adapt to that. So generally the cutting edge is occupied by the code and the manually created artificial intelligence researchers, and the low no-code platforms deal with the bulk of the implementing what already exists, which is why you'll see the spike, the differential and the spike interest between them. However, one interesting caveat to that is if you then apply that to other industries, low no-code app dev, for example, tools like Salesforce have been low no-code for a long time, and testing has become a much more mature discipline. So low no-code is now much more suited to the testing world. In the same way that once machine learning starts to sort of become a more mature discipline, you'll see that low no-code spike above the traditional ML tactics. The end user of an AI platform is a machine learning engineer anyway. It will take a lot of training and consultations for the rest of the team to find their way around AI processes. Very good question. Also a common misconception. The machine learning, so AI platforms for developing AI, yes, machine learning engineers or data scientists more realistically, and machine learning operations engineers. But the usage of AI platforms is something that end users benefit from, and you do today, whether you know it or not. You've got AI in your pocket with your Siri and Assistant. You've got AI even in your email telling you what it works and what doesn't. AI in testing as a platform is something that any manual tester should be able to take care of. If you want to build an AI-driven testing platform, then contact me on LinkedIn because I have a job for you. But also, that is where the machine learning engineering discipline is really needed. If you want to build AI, then machine learning engineering, data science, or machine learning operations are really the paths for you. All right, see, we've got Alex reappearing. Assume that means we're up on time.
We are indeed. We've got, I think, about a minute and a half before the session starts. There is now going to be a session by Tricentis showing the technology, which I'm really looking forward to. So we'll be moving across there in a few seconds. So, Dave, thank you very much indeed. Great session. And thank you, everybody, for the questions. It's been a really lively discussion. So thank you. And I hope you enjoy the demo. And there will also be opportunity to visit Tricentis on the booth after the demo to talk in more detail if you've got more questions. So
I'll also be on the Q&A panel in about an hour and a bit, I think.
Fantastic. Brilliant.
All right.
See you later.
Catch you all there.
Thank you. See you on the demo.